Today we're going to be talking about energy of light, how we use light to determine the composition of celestial objects. These are SLO 1 and 5 from the Waves unit. Our vocab that I want you to focus on today is being comfortable with the term light and electromagnetic spectrum. What is light? Light is a packet of energy, a photon, that is transmitted in electromagnetic waves. The amount of energy will often be referred to as the intensity of the light. If light is classified as bright or dim, it is directly referring to the intensity of the light. And one thing to consider in this classification is the distance of the light source. If a light is closer, the intensity will increase, just as if the light source is further away, the intensity decreases. In this diagram, you can see the same light source with varying distances and how it changes the area. The energy is spread across or scattered, and how the intensity of the light changes. Light in space. Photons travel in waves, and with all waves, we describe the wave with wavelength, frequency, amplitude, and speed. But the thing to note about light is that when in space, a vacuum, the speed of light is unchanging and the amplitude of the wave is the same for all light. The electromagnetic spectrum. Energy emitted from stars is called electromagnetic radiation, and from lowest energy, referring to the amplitude of the wave, to the highest energy, radio, microwaves, infrared, visible, ultraviolet, X-rays, and the most energetic, gamma rays. You will notice the part of the radiation visible is a small portion of the spectrum, and within that visible spectrum, the Roy G. Biv colors of the rainbow are actually representing a wavelength of the photon. Where does the light come from? The sun and other stars are the only source of light in space. Stars have a lot of mass and a very strong gravitational pull towards the center of the star. The center of the star has so much heat and pressure due to gravitational friction between the atoms that it can reach upwards of 15 million Kelvin, while the surface of the sun is only around 5,800 Kelvin. This is enough energy to sustain nuclear fusion reactions, where hydrogen atoms fuse together to form helium, and this releases high-energy gamma rays. These gamma rays then bounce around in the sun and try to reach the surface, and this can take upwards of 100,000 years. Through that process, gamma rays lose some energy and become visible light rays, which then travel in straight lines to our Earth. How do astronomers know what stars and exoplanets are made of using only light? Here you see the unique structure of sodium with the periodic table square and the Bohr model of the atom. Each element is unique in how many protons are in the nucleus. This unique structure will be further explained as we move on as to how astronomers know what elements are in the stars. The light is emitted from the atoms when they are excited. The energy of an atom, when it is excited or heated up, the electrons jump to higher levels of electron orbitals. These atoms then cool off and lose the energy, and those electrons return to their resting state. And as they return, they emit that excess energy in a form of energy called light. The wavelengths released are unique to that element. The color emitted is dependent upon that unique structure of the atom that we referred about to earlier when we showed you the atomic structure of sodium. The bigger the jump from the excited state to the normal state, the more energy is released. The more energy released, you may get a blue photon or a violet photon. The less energy, the fewer jumps in energy back to the resting state, will give you a red or orange color wavelength. Color filters. Now, sometimes the composition of distant clouds on the stars or atmospheres may create almost a filter for the light seen from Earth. These filters can be deceiving to the astronomers and must be considered in the overall evaluation of the makeup of the atmosphere of the objects. For example, the emission spectra of all elements on the periodic table. This is what one element looks like. You can see the 4 different bands of light that are released as the 4 electrons return from these excited states back to their resting state of n equals 2. That is how astronomers know of all the elements that they have seen in stars, that some of the stars have elements as heavy as iron. Blinded by the light.